Hello everyone. This is our CSE 564 Capstone project, and we are of Group 28. My name is Yasaswini, and my teammate's name is Sai Charan. So, firstly, we will be talking about the data set. The reason why we chose this data set is uh, for, uh, because of the particular global nutrition has grabbed everyone's attention. As consumers, we're all familiar with the little nutrition facts panel on packaged foods or whatever they might be, as whether it might be breakfast cereal or granola bars or anything. These labels tell us exactly how much calories, grams of fat, carbohydrates, and proteins we're putting in our bodies every day. So every bite counts. So think about our daily routine. Like every day we'll have more amount of calories, and even in that we need to know our nutrition values, right? So the first thing which we'll be talking about is our where we got these data sets from. We got these data sets from Food and Agriculture Organization, World Health Organization, and World Data. We have clubbed these data sets, merged these data sets. The data sets were around from 1900s, and we have sampled these from 2000 to 2022, around 23 years. And this also consists of around 180 plus countries, and this data set integrates the values of calories and macronutrient figures, life expectancy, and there are multiple metrics like daily calorie supply, grams of fat and protein, prevalence of undernourishment, which allows us to talk about many questions like how does wealth translate to nutrition, where do bottlenecks remain. So by visualizing these relationships, we can pinpoint the regions stuck in a nutrition trap like low GDP, low calories, and low life expectancy, and even advocate for the targeted policy interventions. That's the one reason we chose this data set. So I'll just hand over to my teammate where he'll be explaining about all the technicalities which are involved in this dashboard.
Hi everyone, this is Sai Charan Jakkula. So I'll be talking about the technical visual implementation and the interactions between these graphs. Uh, for this project, we chose five visualizations. The one at the top right is a choropleth map, and the one beside it is an scatter plot with bubble chart, and also we have a PCP plot, and also we have a radar plot and a tree map. I'll go through one by one. Let us have a look at the choropleth map. So, uh, in the choropleth map, I have used the visualization technique called zooming and panning. So I can zoom in into the map, and I can pan the map, and I can uh, I can hover the map. So this map basically shows the daily calorie supply by country. Uh, so it, so in India, in the year 2022, the daily calorie supply is uh, 25 2574. So if we can also scroll the time chart, so that we can see different values. As you can see, all the charts keep changing when we scroll the time bar. So so the features of the choropleth map that we included are, so on hovering every country, we see the daily calorie supply of that country per person, and there is an option to select multiple. Not only hovering, we can also select the country. By selecting the country, all the other maps reflect the selected country's metrics. So as you can see in the PCP, we can see there is a line highlighted, which shows all the values: daily calories, life expectancy, GDP, undernourishment percentage, everything. And also in the scatter plot, we can see the highlighted diagram. In the scatter plot, in highlighted diagram, and also in the distribution of protein, we can see uh, there is India and how much, what is the distribution, and we can see the dietary energy composition. So basically, in here we can also select multiple countries at once by holding on command. And now I have selected a few countries in Africa too. So as you can see, the remaining charts reflect all these countries. So therefore, I had introduced linking here in this map. Now let us go through. This can be resetted by clicking anywhere on the screen. Now let me go through the bubble chart. So for the on the details of the bubble chart, the sizes of the bubble are directly proportional to the population density of the countries. So for countries like India and China, where the population density is very high, the size of the bubble is pretty big, as you can see. And for countries like United Nations, where it is less densely populated, or some African countries or countries like Antarctica, the population bubble is very small. So, and also we have introduced zooming and panning in this chart, and uh, we have also introduced linking and brushing. As you can see, I can select few countries in the scatter plot by brushing. Thereby, these countries get highlighted in the PCP plot, and these countries get highlighted in the uh, choropleth map, and the average values of these countries will be displayed in the distribution of protein and the dietary energy composition. And coming to the PCP plot, so in the PCP plot, uh, we also introduced linking and brushing in the PCP plot. On hovering over a line, we can see there is a dot highlighted in the bubble chart, and there is a country highlighted in the choropleth map, and all these details can be seen. On clicking on the line in the PCP plot, also uh, we can highlight it. And we also introduced linking and brushing in the PCP plot. Let me do that. So I have filtered some part of the data where you can see it got highlighted in the choropleth map and the scatter plot, and uh, the average of these values are displayed basically in the displayed basically in the protein and energy composition. So and we basically used edge bundling here, so that there is a little, as you can see, by not being a straight line, the lines are a little bit curved. So we use the visualization technique called edge bundling here to bundle the edges. And there is also another two distributions. One is the distribution of protein, which is a radial plot, which contains which basically contains uh, the distribution of vegetables, the distribution of protein which comes from vegetable, which comes from fish, meat, eggs, and milk. On hovering on each country, we can see which how much amount of protein source comes from which kind of protein source, and there is also dietary energy composition. If you can see, India consumes a lot of carbohydrates, around 69.1%, and a lot of it. And let me select one country and see. So the selected country is Democratic Republic of Congo, where it has 83.5% of its energy comes from the carbohydrates, and 4.9% comes from vegetable protein, and 10.9% comes from fat, and 8% comes from cereals, roots, and tubers. Uh, and also, yeah. And also on every chat, we can basically see the timeline by scrolling down the time series, where we can see on scrolling, this is the data in 2003, and this is the data in 2010. Now, the basic and now some insights on the scatter plot and remaining insights what we found with the data will be explained by Timet.
Okay, yeah. Coming to the insights, as we can see in the choropleth map, all the darker ones which are having higher calories are uh, blue, I mean more dark in color, and the ones in the gray are having the less calories. Well, if we can see, the first insight would be like the nutrition cliff and the plateau, where we can see in this in the bubble chart, that low income threshold, like around less than 5K, their kilocalorie count is around 2,400 per day, and even their life expectancy is also less than 65 years, if you can see. So yeah, for all the GDP less than 2K, it's around 50 to 60, and between 60 65, that's it. That was the average. And for the countries with mid-range, like calories with around coming, I mean, like in with their GDP around 5K to 20K, these calories would be around to 2000 to 3000. And and for the plateau, which is around GDP, which is around 20K, more than 20K, their calories are around more than 3000 to 3500 and 400, like so. With this we can depict, with the higher GDP, the more calorie intake per person. And for the second insights which we can see would be, um like for example, if we take in the PCP plot, this country is for, I guess it's for Somalia. Yeah, for the Somalia, it's around 1812 kilocalories. And if you see the GDP as well, it's just less than 2K. And their undernourishment rate is also more than 50, around like around 50%, which also directly depends on the GDP. And if we see the trends, the less the GDP, less the life expectancy. And even with calorie per supply per person is also getting increased gradually with GDP. So by this we can depict saying, the country's GDP plays a major role for all the calorie intake and life expectancy as well. Like all the trends, if you can see that just based on the GDP itself, they are getting in an upward trend with the GDP getting increased. And one example we can be specific about is for Japan. If we um let me just point out to Japan. Yeah. So for Japan, as we see, even with the calories, high calories, like around approx 3000, it's approx 3000 kilocalories. The life expectancy is almost greater than 84 years, if you can see over here in the bubble chart. And their fat and protein shares are also moderate, which is an example of a balanced, healthy nutrition. And their lifestyle is also great. We can depict from that, and their healthcare is also very good. So, and coming to the Dubai or UAE, let me just zoom in this. This is Yemen. I'm not sure where it is. Okay, but what we have depicted was like even for the ones with Dubai with higher GDP, or also their calories are also more, and their GDP is also high. But their life expectancy is around 77 to 78 years, which is lower than peers like Switzerland and all that. This signals the potential lifestyle or environmental health challenges. And coming to Brazil, this has like 3,384 kilocalories, which also has more calorie intake. Yet there's undernourishment over there's undernourishment around 10%. I mean, with having the higher GDP, also they do have undernourishment. So, which is a red flag that wealth gains are not uniformly distributed across the populations. Even with their GDP is around more than 28, their life expectancies are is around 70 years or something like that. So yeah, that concludes the insights which we got. So overall, we can say the global average calories from 2000 to 2022 rose by around 150 to 200 kilocalories for yeah, that's like if we can see the trends which are getting darker, and their life expectancy grew rapidly. And yeah, these are the insights which we could depict from this dashboard. Thank you.